So RAID with EBS volumes. So RAID stands for Redundant Array of Inexpensive or Independent Disk. And what is RAID? RAID is the ability to combine multiple disks for speed, performance, capability, and fault tolerance. So the common combinations we have are RAID 0 and RAID 1. We have other combinations such as RAID 5, RAID 10, RAID 3, but in this presentation, I'll talk just about the common ones being used currently in the cloud. So for RAID 0, which is the first diagram I have to the left of the screen, RAID 0, you have two hard drives. So let's say you have hard drive 1 and hard drive 2. Now, what RAID 0 does is it takes your data and it splits it equally or evenly across your hard drives. So it separates your data into blocks and it splits them evenly across your hard drives. So you have these two hard drives connected. So let's say we have a statement, or the data here is welcome to EBS day. So what it does is it separates your data evenly across these two hard drives. You have welcome and you have 2 into the other drive. You have EBS and you have day into the other drive. So with this combination, you have more space or more storage capacity here. And you have ultimate speed, given that you have more space, that gives you ultimate speed. But the downside of this RAID combination is you do not have redundancy. And another downside to it is if one of your hard drives fail, you lose half of the data you have stored in the hard drives or in your RAID 0 system. So those are the downsides for the RAID 0. Moving on to the RAID 1, which is the diagram in the middle here, you have mirrored disk. So this 2 here, or hard drive 2, is literally a mirror image of hard drive 1. So you have welcome to EBS day stored in one drive, and the second drive, or the second hard drive, as a carbon copy of the previous one. So you have the same thing stored onto the second hard drive. And with that, you have improved availability. You have ultimate redundancy, but you might have slow performance because your system still works literally on the same storage capacity of a single hard drive, given that they're mirror images of one another. And in a case of failure, in an event of failure, all you need is one hard drive. So let's say the first hard drive fails, all you need is a second hard drive to recover your system. And in a RAID 1 scenario, we're limited by the speed and the capacity of the smallest hard drive that is attached to a RAID 0 system. And that takes us to a RAID 10. We have a RAID 5 that is currently not being used in the cloud as of now. So moving on to a RAID 10, you have 1 and 0. So it's literally a combination of RAID 1 and RAID 0. Use 4 or more hard drives so you have the first 2 or the last 2 being mirror images of the first 2. So you have a RAID 0 combined to a RAID 1. That is how you get a RAID 10. So you have RAID 1 over here and you have a RAID 0 over here. So RAID 0, as I had mentioned previously, is your data is split evenly between your hard drives. So once you split your data between your hard drives, you get a RAID 0. So that is a RAID 0 right over here, the first 2 hard drives. Now, the second hard drive being a mirror image of the first hard drive, that gives you a RAID 1. So a RAID 10 gives you a combination of speed and performance. So it's a combination of the speed from the RAID 0 and the performance from RAID 1. And RAID 10 as well, in an event of failure you're able to recover. You're able to recover your system because you have a duplicate system from the other two hard drives. So you can easily recover your system from the two running hard drives at any point in time. So only one hard drive in a mirror set can fail. So only one hard drive here can fail at a time. So let's say the first hard drive in the first two hard drives where you have the RAID 0, this one fails. You can use this one to recover the system.